Okay. Section 0.4, polynomials. So let me first define a polynomial in one variable. So a polynomial in x, denoted by, well, let's say the polynomial is p. We say that p of x is a polynomial with coefficients in some field, f, let's say, in some indeterminate, let's call it x. So, p of x is a polynomial if it's of the form the sum I equaling 0 to n of a sub I times x to the I, where a sub I is in some field f, and where n is a whole number and a sub n, the leading order coefficient, not equaling 0, then this has degree n. So a polynomial consists of terms. Each term consists of a variable part, a coefficient, a numerical coefficient, so a numerical coefficient, and some variable part. Now the variable part might be missing, so it's 1. The degree of a term is the sum of the exponents of the variables in the term. So suppose I have negative 5ab squared c to the fourth, where a, b, and c are variables. Then the degree of this term is, well, the exponent of a is 1, the exponent of b is 2, the exponent of c is 4. 1 plus 2 plus 4 is 7. The degree of a polynomial is the largest of the degrees of each of its terms in the polynomial. We will denote that by degree of p. Let me give you some further terminology. A monomial is a polynomial with one term. A binomial is a polynomial with two terms. A trinomial is a polynomial with three terms. A term is said to be a constant term if the degree of that term is 0. We also say that a polynomial is constant if its degree is 0. A term is said to be linear if the degree of that term is 1, and a polynomial is said to be linear if the degree of that polynomial is 1. A term is said to be quadratic if the degree of that term is 2. A polynomial is said to be quadratic if the degree of the polynomial is 2. A term is said to be cubic if the degree of that term is 3. A polynomial is said to be cubic if the degree of that polynomial is 3. A term is said to be quartic if the degree of that term is 4. A polynomial is said to be quartic if the degree of that polynomial is 4. A term is said to be quintic if the degree of that term is 5. A polynomial is said to be quintic if the degree of that polynomial is 5. The leading order coefficient is the coefficient for the term with the largest degree in the polynomial. We denote that leading order coefficient by LOC of the polynomial, let's say p. A monic polynomial is a polynomial where the leading order coefficient of the polynomial is equal to 1. Let's do some examples. So on page 50, let's do problem number 12. Determine whether the given expression is a polynomial. If so, tell whether it is a monomial, binomial, or a trinomial, and give its degree. Okay, so yes, this is a polynomial. Because it consists of, well, in this case, two terms, consisting of a numerical coefficient and of a variable part. This variable part consists of actually two variables. The exponent for each of these variables are equal to 1, which is a whole number, and a second term whose numerical coefficient is -1 and whose variable part consists of one variable, x, to a whole number exponent 3. So since it has two terms, this will be a binomial. And lastly, I want to determine the degree of this polynomial. Well, the degree of this term is 2. 1 plus 1 is 2. The degree of this term is 3. Therefore, the degree of the polynomial is 3. Okay. 0. Is 0 a polynomial? Sure. I mean, it's 0 times 1, and so it consists of one term. So yes, it's a polynomial. It's a trivial polynomial. Next, well, how many terms does it have? 1. So it's a monomial. And lastly, what is the degree of this polynomial? Well, the degree of this polynomial, well, if it's a constant like 2 or something, the degree of that polynomial would be 0. But we want that 0, the polynomial, the 0 polynomial, to actually have degree less than any other polynomial. So we could let it equal any negative number. We'll actually let it equal -infinity. Why? Well, by convention. So by convention, we let the polynomial have degree -infinity. Okay, problem 32. Oh, I forgot to write down what they're asking us, which is probably to simplify. Okay, so I would imagine, let's see if I can, well, let's see if I can find the instructions for this. And it has to be something like simplify the polynomial or something to that effect. So this is on page, so this is problem number 32. Perform the operations. And simplify. Okay, so that's the instructions for that. And so, let me do problem number 32. So let me just multiply 3m inside the parentheses, negative 6m inside, 3mn inside the parentheses, negative 6m inside the parentheses, negative 2n inside the parentheses. So this is equal to 3m squared n plus 6mn squared minus 18m squared n minus 6m minus 8mn squared. Minus and minus is a plus 2n. So let's combine like terms. And so I have here a 3m squared n minus 18 is minus 15 m squared n. I have a 6mn squared minus 8mn squared is a minus 2mn squared. I have minus 6m plus 2n. And that is your answer. Notice there are no other like terms that we can simplify. A like term is a term that has identical variable part. So since the variable part of this term here is m squared n, and the variable part of this term here is m squared n, then you just have, well, let's say 3 apples minus 18 apples is negative 15 apples, and you keep the apples. Let's do problem number 42. So I'm going to multiply these together. Let's multiply y inside the parentheses, then negative 5 inside the parentheses. And so I get y times y squared, minus 5y, minus another 5y, minus 5 times minus 5 is plus 25. Well, these are like terms, so let's combine them. So we get y squared minus 10y plus 25. And that is your answer. Let me do problem number 45. And so let's multiply those together. Let's multiply by y, and then multiply by by positive 4. So this is equal to x squared minus 4x plus 4x minus 16. Notice I can combine like terms. The 4x's cancel. And so I just get x squared minus 16. And that is your answer. Okay. So let's recall the special product formulas. These last two problems were examples of special product formulas. We just didn't say it. Okay, so the first of the special product formulas, the product of the sum and difference of two terms is the difference of their squares. Okay. Well, actually, I should sort of note this. Maybe I should just I'll put it here as sort of a remark in between the two. So this is just sort of a note. The product of real polynomials can't equal the sum of squares. So I have the difference of squares, but I won't be able to get the sum of squares if I'm dealing with polynomials that have only real coefficients. Okay. Next, the perfect square. So maybe I should actually say that here. This was the, well, eventually it'll be called the difference of squares. Or the product of the sum and difference of two terms. These will be called the perfect square trinomials. So I have that a plus b quantity squared is a squared plus 2ab plus b squared. A minus b quantity squared is a squared minus 2ab plus b squared. I have here the sum of cubes. A plus b times a squared minus ab plus b squared is a cubed minus b cubed. I have the difference of cubes formula. A minus b times the quantity, a squared plus ab plus b squared, is equal to a cubed minus b cubed. And lastly, we have the perfect cubes. A plus b cubed is just a cubed plus 3a squared b plus 3ab squared plus b cubed. Also, a minus b cubed is a cubed minus 3a squared b plus 3ab squared minus b cubed. You need to memorize these special product formulas, mostly for when we do factoring. So if you write these formulas in the opposite direction, these are factoring formulas, and so they'll be very important for factoring. Let me do, on page 51, problem number 63. So again, it just said to, what was it, simplify or something like that. It said, perform the operations and simplify. So let's do that. So problem number 63. Okay, will you stop? Okay. I obviously went too far. Here it is. Okay, so let's do this. And so this is equal to multiply by rad 5 by 3x. So I get 2 rad 5 minus, well, rad 5 times rad 5 is 5, so I get a positive times negative is negative. So rad 5 times a negative 5 rad 5 is 5x. 3x times 2 is 6x. 3 positive times negative is negative. 3 times rad 5 is 3 rad 5. And x times x is x squared. And so this is equal to 3 x squared rad 5 6x minus 5x is 1x plus 2 rad 5. And that is your answer. In general, we write the radicals last. Otherwise, we need a parentheses. 66. So, let's just use the special product formula. So a minus b cubed is a cubed minus 3a squared b plus 3a b squared minus b cubed. 2 cubed is 8. X cubed is x cubed. 2 squared is 4 times 9 is 36 x squared. 3 squared is 9 times 3 is 27 times 2 is 54x. 3 cubed is 27. And that is your answer. Let me do problem number 82. Multiply the expression as you would multiply polynomials. So this is equal to, well, it's one of the special product formulas. So it's the first term, you square it. Well, so this will be x to the 3 halves squared, but 3 halves times 2 is 3. Plus 2. So you just multiply this term times 2. So you get a 2. X to the 3 halves, y to the 1 half, plus y to the 1 half squared. Well, the 2's cancel, so you just get y to the first. And that is your answer. The division algorithm. So, just like with numbers, with, well, natural numbers, with integers, you can divide two integers so long as you're not dividing by 0. And you can do the same thing for polynomials. Polynomials really sort of act like integers. They have more or less the same properties that integers would have. And so, the division algorithm. The division algorithm for integers states the fact that you can divide two integers so long as you're not dividing by 0. So let P be a polynomial. Let's call it P of x. Be a polynomial. And let D be a polynomial. Not a non-zero polynomial. Then there exist polynomials Q and R such that P of x, the dividend, is equal to Q of x, the quotient, times D of x, the divisor, plus R of x, the remainder, where R of x is such that it's smaller than the divisor. The degree of R is less than the degree of D, the divisor. And so this is the same when we had, let's say you're dividing 21 divided by 5. You get 4 1/5. Well, you can't really write so polynomials in a mixed number notation. So let me say that really, if you were dealing with polynomials, it's better to say, well, 21 over 5 is 4 plus 1/5. If you multiply both sides of that by 5, you get that 21 is equal to 4 times 5 plus 1. So a dividend is equal to some quotient times your divisor plus a remainder. It is the same that I wrote above, the division algorithm. So on page 51, let me do the following. Perform each division and write all answers without using negative exponents. So I'm going to look at the case where I'm doing a polynomial divided by a monomial. So I have 9a cubed, so there's 108. 9a cubed b to the 4 plus 27a squared b to the 4 minus 18a squared b cubed, all divided by 18a squared b squared. So this is equal to 9. So let's divide each term. 9a cubed. Okay, I need more space there. 9a cubed b to the 4. Let's divide this by 18a squared b to the 7 plus 27a squared b to the 4 over 18a squared b to the 7 minus 18a to the squared b cubed over 18a squared b to the 7. So this is equal to, well, let's see, 9 divided by 18 is 1/2. Oh, and a cubed divided by a squared is a. B to the 7 divided by b to the 4th is b cubed. I can divide both 27 and 18 by 9. The a squares cancel. B to the 7 divided by b to the 4 is b to the 3 minus the 18's cancel, the a squares cancel. B to the 7 divided by b to the 4th is divided by b to the 3rd is b to the 4th. And that is your answer. Okay, next. Perform each division. If there is a non-zero remainder, write the answer in the form quotient plus remainder over divisor. So I want to write it in that form. Okay, so let's divide. So this is my dividend. This is my divisor. So let's divide. Two x squared minus 19x plus 37. And this is 2x minus 5. So 2x squared divided by 2x is x. Let's multiply by x, so I get 2x squared minus 5x. And let me subtract. The 2x squares cancel. Negative 19x minus a negative 5x. 5x minus 19x is negative 14x. Drop down to 37. Negative 14x divided by 2x is 7. So let's subtract. And so I get 14x. Oh, wait. I have the wrong sign. I have negative 14x minus 5 times minus 7 is positive 37. And now let's subtract. The negative 14x is cancel. 37 minus 35 is 2. So note that this is my dividend. This is my divisor. Now this term up here will be my quotient. And so long as the degree of this term is less than the degree of the divisor, which it is, 0 is less than 1, and so that means that this is my remainder. And so I can write my answer as follows. So I have that this is equal to x minus 7 plus the remainder 2 over the divisor 2x minus 5. So this is my quotient. And then this is my remainder over my divisor. Okay. So that's my answer. Okay. Let's do problem number 117. And so x to the fifth minus 2x cubed minus 3x squared plus 9, divide that by x cubed. Well, luckily everything's descending order, but there's some terms here that are missing. So let me put in, there should be an x squared term, there should be an x term, and a constant term. There should be an x to the fourth term. There should be a term involving x. So I just put in the ones that are missing, and now let's finish this. And so let's multiply by x squared. X to the fifth divided by x cubed is x squared. So let's multiply that out. So that's going to be x to the fifth plus 0, x to the fourth plus 0, x to the third plus 0, x squared. And now let me subtract. X to the fifth cancel, but then you get 0 minus 0. Well, those can't, that's 0. Negative 2x cubed minus 0x cubed is a negative 2x cubed. Negative 3x squared minus 0 is a negative 3x squared. There are 1, 2, 3, 4 terms here, so let's drop down 2 more terms so that this has the same number of terms as my divisor. And so negative 2x cubed divided by x cubed is negative 2. And let's multiply. So I get a negative 2x cubed plus 0x squared plus 0x plus 0. And let's subtract. The 2x cubes cancel, and so I get negative 3x squared minus 0. X squared is negative 3x squared. 0 minus 0, well, that cancels. It's 0. 9 minus 0 is 9. And so my answer is x squared minus 2. I don't need to write the zeros in. Plus, let me go down one more. Plus negative 3x squared plus 9 divided by x cubed. And that is my answer. Notice that the degree of negative 3x squared plus 9 is 2. The degree of x cubed is 3. Therefore, this is a remainder, since its degree is less than the degree of the divisor. Okay, synthetic division. Well, in synthetic division, it's a simplified way of writing what we've done here in long division. So, set the denominator to 0 and solve for x. Or another way of thinking about this is if there's a coefficient, if this is a monic polynomial, a monic linear polynomial, then just take the opposite sign of what's here in the divisor. So now all I'll do is I'll only write down the coefficients of the polynomial in the dividend, and I'm going to do this as a placeholder system, so I need to put in the zeros. Above, it was convenient to put in the zeros, but it wasn't necessary. Here you must do it. So it's 2x cubed plus 0x squared plus 0x plus 1. And so, let me do this. So drop down to 2 times 1 is 2 plus 2 plus 0 is 2 times 1 is 2 plus 0 is 2 times 1 is 2 plus 1 is 3. And so, my answer is, I started with a cube. I divided by a polynomial degree 1. Therefore, my quotient will have a polynomial will be a polynomial degree 2. So this is 2x squared plus 2x plus 2 plus, well, the remainder here is 3 over my divisor, x minus 1. And that is good. My answer. Okay, let's do problem number 111. And so, let me set the denominator to 0 and solve for x. So add 5 to both sides of the equation, divide by 2. So, I have the following. So let's put in 5 halves. So I have 2x squared plus minus 19x plus 37. Drop down to 2 times 5 halves. 5 minus 19 is negative 14 times 5 halves. Well, 14 divided by 2 is 7 times 5 is a negative 35 plus 37 is 2. Now, let me divide each of these by 2. But I won't divide the denominator by 2. Let me just leave it that way. And so if I do that, this will equal 1, this will equal 1, and this will be 2. Negative 7. And so, my answer is x minus 7 plus 2 over 2x minus 5. And that is your answer. Okay, let me do problem number 122. And let's try to do this using synthetic division. So first off, my divisor can be written as 6x squared plus x minus 12. And so I can factor this as 2x plus 3 times 3x minus 4. Okay. Now, first off, let's set 2x plus 3 equal to 0. So x is equal to negative 3 halves. Next, set 2x, 3x minus 4 equal to 0. So x is equal to 4/3. Okay, so let's do this. And let's write everything in descending order. Let's do the 4/3 first, I guess. Doesn't really matter which one I do first. And so I have here 36x to the 4 plus 72x cubed minus 121x squared minus 142x plus 120. Drop down to 36. Divided by 3 is 12, times 4 is 48, plus 72 is 120, divided by 3 is 40, times 4 is 160, minus 121 is 39, divided by 3 is 15, divided by 3 is 13, times 12 is, okay, let's try this again. 39 divided by 3 is 13 times 4. 13 times 4 is 52. And so I get negative 90. 90 divided by 3 is 30, times 4 is 120. So if you add these, you get 0. Okay, so now I have also negative 3 halves. So let's continue with my synthetic division. Notice that I am going to have to do synthetic division twice because I factored into 2 linear terms. Okay, so now let's maybe I'll just do it here. Doesn't really matter. Let me drop the 36 divided by 2 is 18 times 3 is 54 minus 120 minus 54 is 66 divided by 2 is 33 times negative 3 is 99 minus 39 is a negative 60. Negative times negative is positive. 60 divided by 2 is 30, times 3 is 90. And so you get 0. Now, since I had a 6, notice that these denominators are both 2 and 3. I should have actually divided either at the beginning or the end by 6. So let's divide each of these terms at the end by 6. Oops. So let's do that. And then I'll be able to determine my answer. So let's divide by 6. If there was a remainder, I wouldn't divide by 6. So if I do that, this is equal to 12, 11, negative 10. And so my answer is, why is 36 divided by 6 is 6. And so I get 6x squared plus 11x minus 10. And that is my answer. And notice that there's no remainder. And so it's just a quotient. Okay, so that finishes off section 0.4. So that's it for today. Okay. How am I ever going to do this? Okay, let's see. There it is.